Hello friends, welcome to Shiksharthi. In this video, we shall be solving question number 5 of exercise 8.4 on trigonometry. So let's start. Question number 5 asks us to prove the following identities where the angles that they have given in any identity. For example, question 5 consists of 10 subparts. It's quite an exhaustive question. So here is where your learning will be harvested totally. Okay, so they have already given, you are supposed to prove this. Here the best way to prove is when you are supposed to prove an identity, take the left hand side value as LHS, take the right hand side value as RHS, and then establish finally that LHS is equal to RHS, and then finally you write hence proved. Right? Okay. So these are the identities. This is subpart 1 and this is subpart 2. We shall prove this. So again, as advised, we would take the left hand side value first. So let's say the left hand side value here is this. So what is cosec theta? Cosec theta is hypotenuse upon, and cot theta is base upon perpendicular. So this is the value that we need to calculate. Right? At the same time, the RHS value, RHS, is nothing but 1 minus base upon hypotenuse divided by 1 plus base upon hypotenuse. So there are three things which are given to you. Other than this piece of information, there are two more things which are given to you, which are understood being given. One is the PBH rule. You should know the trigonometric ratios in terms of PBH. Second thing that you are expected to know is the Pythagoras theorem. Third is the question that they are given to you. Using these three values or these three pieces of information, you can solve any identity. You can prove any identity. Okay. So now here, can I say this is nothing but just like saying h minus b upon h plus b? This is what we need to establish. Okay. So I'm just drawing a thin line in between so that we are able to solve this. So can I say this is just like saying h square plus b square minus 2bh divided by p square. Okay, and we need to remove the p from here, because if I have to equate it to the right hand side, so right hand side answer is only in terms of h and b. Here the numerator has an h and b, but the denominator does not. So this comes to you as a piece of advice. Anyway, so now can I say that, okay, so the numerator is h square plus b square minus 2bh upon h square plus b square. Right? So either I solve this side or I solve this side. Is up to you how you do it. But I hope this has been done correctly. So the question here was cosec theta minus cot theta. Okay, so cosec theta is hypotenuse upon base minus, hypotenuse upon perpendicular minus base upon perpendicular whole square, and then we expanded. Okay, so what do we do after this? So one is this is, I can just write it like this is h minus b whole square and divided by how much? B square, keeping in mind that now the moment I write this as h square plus b square, I will not be able to equate it to the other hand side. So what do I do in this case is the point that needs to be understood by us. So what should we do? So now if I open it out as h square plus b square, okay, so does it help me in terms of expanding it in terms of the factors given? Does it help me? Okay, let's see this out. So did we do this correctly? So this was just like saying h minus b upon h plus b. Okay, so now if I see the right hand side value, if I multiply both the numerator and the denominator by h minus b. So now this reminds me, the moment I have written this as h square plus b square, this expression is incorrect because p square is not h square plus b square, it is h square minus b square. So the moment I would have written it like this, I need to be attentive here. But anyway, so now here, if I multiply both the numerator and the denominator by h minus b, so I get what? H square minus b square, h minus b whole square in the numerator divided by, how much is h square minus b square is equal to p square. So can I say LHS is equal to RHS? Yes. Okay, let's move on to the second question. So this is how much? This is base upon hypotenuse and divided by 1 plus perpendicular upon hypotenuse, plus this is 1 plus b by h. So we are saying what? This is the left hand side value divided by b by h. Similarly, now if I have to equate it to the right hand side value, the right hand side value is how much? This is 2h by b. So all we need to understand from here is the right hand side value is having only h and b. So we need to eliminate b. Let's see how will we eliminate b from here. Can I write it like this is b divided by h plus b? H plus p plus h plus p divided by h. Now once I take the LCM, can I write it like this is bh plus h plus p whole square upon hb. Going further, can I write it like this is hb or bh plus h square plus p square plus 2ph upon bh. Now what to do after this? So now we know that the other hand side, it is only using what? It is using only h and b. But before we go ahead, let us see have we done it correctly or not. So this is base upon hypotenuse divided by 1 plus perpendicular upon hypotenuse plus 1 plus sin a divided by cos a. Okay. So I think fair enough. No, this should have been written as b. So we again committed a mistake here. Okay, so once we have written it like this, now after I take the LCM, can I say this is nothing but saying b square plus h plus p whole square divided by b times of h plus p? Yes. And after this we could have written it as this is nothing but b square plus h square plus p square plus 2ph divided by again b times of h plus p. Now if I use this and this, I'll be able to say that p square plus b square is equal to h square. So eventually we'll be able to say this is 2h square plus 2ph divided by b times of h plus p. So I'm just bringing it this side. Now if in the numerator, if I take 2h as common, so I get twice of h plus p divided by b times of h plus p. Now h plus p gets cancelled out and you get the right hand side value. So once you get the value, you'll be saying LHS is equal to RHS, hence proved. Okay, let's move on to subpart 3. So in subpart 3, they have asked you to prove tan theta upon 1 minus cot theta plus cot theta divided by 1 minus tan theta is equal to 1 plus sec theta into cosec theta. Okay, again let us use the PBH rule. So can I say this is P by B divided by 1 minus B by P plus B by P divided by 1 minus P by B. So once we solve this, can I write it like this is P by B into, now in the denominator I will be getting P minus B, right? But in the numerator this P goes up, plus I can write it like this is B by P and this B goes up. And before we would have started, we should have written that we are calculating the left hand side value. Okay, so now this B divided by Let us say b minus b. Okay, now this further can be written as, can I take 1 divided by p minus b as common? Yes. And then inside, what will I write? I'll write p square by b minus b square by p. And eventually you will write it like, this is 1 divided by p minus b multiplied by p cube minus b cube divided by pb. So what I was talking about in the first two questions, other than the PBH concept and the Pythagoras theorem, the third thing which is important here is something that you would have already done in the past in terms of your studies. And what are you expected to know? You are expected to know whatever you would have done till date, but more than that, you are expected to know quadratic equations, quadratic expressions, cubic expressions, algebraic expressions is what I want to say. That means you should know how to expand p cube minus b cube. Now when I expand p cube minus b cube, I will say p cube minus b cube is equal to p minus b into p square plus b square plus 2pb divided by p minus b into pb. So this gets cancelled out and eventually you'll write it like, now before you go ahead, you know that sec theta. So if I calculate the right hand side value first, so can I say the right hand side value can be written as 1 plus h by b plus h by p. I'm sorry, not plus, multiplied. So this is what you are supposed to prove. Okay, so when I write the left hand side further, can I write it like, this is nothing but p square plus b square becomes h square. This is one way. Or what we can do here is, okay, let's go ahead like this only. So let's say h square plus, now h square divided by pb plus now 2pb divided by pb, which can be written as what? Okay, this expression is written incorrectly. This is p cube minus b cube is equal to p minus b into p square plus b square plus pb, not plus 2pb. Okay, so now pb divided by pb gives me 1. So can I say this can be further written as 1 plus h by p into h by b. This is equal to RHS. So henceforth you can say LHS is equal to RHS, which means hence proved. Okay, talking about this question which says 1 plus sec a divided by sec a is equal to sin square a divided by 1 minus cos a. We'll do the same. We'll first take the left hand side value. So the left hand side value can be written as 1 plus hypotenuse upon base divided by hypotenuse upon base, which means this can be written as b plus h upon h. Similarly, RHS value, sin square a is nothing but p square upon h square divided by minus cos a, which is nothing but b upon h. So can I say this can be written as p square upon h square divided by h times of h minus b upon h square. So what I have done here is, this could have been written as h minus b upon h. So I multiplied the numerator and the denominator both by h. What was the objective? The objective is to get an h square so that I can cancel these out. So eventually you write it as p square divided by h times of h minus b. So what do I do after this? Because I am supposed to get the left hand side value is h plus b. So now from here we get a hint. Now what is the hint that we get from here? The hint that we get from here is, we know that p square can be written as h square minus b square divided by h into h minus b. Now h square minus b square is nothing but h minus b into h plus b divided by h into h minus b. So you will be able to say LHS is equal to RHS, hence proved. Now please recall, I said that using LBH you will never tax your brain. It becomes so smooth that you are not supposed to remember anything other than those two things which I talked about, plus whatever you would have done till date. If you feel that this video is really knowledgeable and informative, and it really helps you to solve the questions on trigonometry completely and correctly. Please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do some videos on specific topics or difficult topics, do not hesitate and put it in the comment section. Thank you so much. Until next we meet, goodbye.